goes now to India. So South Africa is our main supplier, was replaced by Russia. And I have to say that we are very highly dependent on energy imports in Europe, with in oil around 85%, 90%, in gas around 70-75%, but it's increasing. And in all energy sources, coal, oil, and gas, our main supplier is Russia. And we address these high import dependency in different actions of our energy policy. So here I show you the figures about the installed coal-fired generation capacity in the EU member states. You see here the highest coal capacity you will find in Germany with 45,000 megawatt, and then the next second place is taken by Poland with nearly 30,000 megawatt, then already UK, and then we have countries like Sweden, which nearly have no coal use in the electricity sector, and other countries. So it's quite a big range of coal utilization in our European member states. And here this one credit point shows you the percentage of coal in the electricity mix. So Poland has a percentage of nearly 90% of coal use for electricity generation. In Germany it's around 42%. And other countries like Spain, it's around 55%. So that is quite important, this overview to see what for all the coal plays in the different member states. I come to some energy policy developments in the European Union. I don't want to go in details, only to show you that we are very active in the field of energy. The main regulations are on liberalization of the energy market. And regulation on security of gas supply, energy infrastructure, energy efficiency, renewable energy directive. There are so many pieces of legislation guidelines which are adopted because we have a common EU energy policy. We are regulating most of the energy areas. One thing which we don't regulate in Europe is the electricity mix. The electricity mix, the use of the energy sources, are you going for gas, are you going for coal, are you going for nuclear renewables, is up to the member states. That is not regulated by the European Commission, but we are regulating the framework and the environmental sustainability of the energy sector. That one of the pieces of regulation or scenarios is the energy roadmap, where we have looked already at the different scenarios towards 2050, quite long-term scenarios. And at the slide I show you that we have, sorry about that was too much, and that we have this is the current installed coal capacity in Europe, 187 gigawatt. And if we continue our policy like here now, we come to 2050, 104 gigawatt, but we want to decarbonize our society, our economy. So we have a target of CO2 reduction of around 85-90%. And to achieve this target, we have to decarbonize. So one of the scenarios says 84 gigawatts, but there are other scenarios which say there's no oil for coal. But I'm showing this scenario and the main statement of this energy roadmap, which says that we have to develop CCS and other emerging clean technologies. Otherwise, coal won't play a role towards 2050. Otherwise, we can't achieve our CO2 reduction targets. But CCS has to be used not only in the coal sector, has to be used by gas-fired plants, and has to be used in the energy-intensive industry. That is our clear statement that we need CCS in the future. And that is our main discussion nowadays about the 2030 framework for climate and energy policy. So we are now working on a policy and strategy targets for 2030, and this is an ongoing process. We will have a proposal in January 2014, and I show you these are the three target objectives of the energy policy. And I had a talk with Mr. Krishna. He said it's the same in India. The so-called energy triangle, which we have to solve, and we have this target to ensure sustainability, where you have reduction of emission, climate change issues, reduction of energy consumption, etc. We have to ensure security of energy supply, the diversification of energy sources, grid stability, adequate energy infrastructure. But the main point, also for part of Europe, is we have to solve competitiveness. We have to maintain our competitiveness. We are in a very hard competition between European industry and American, and a hard competition between also China nowadays. So Europe is really relying on exports, and if we have to have affordable competitive prices. If we don't, if we increase our electricity prices too much, we won't be competitive anymore, because our electricity prices in Europe have the double price, they are double of the United States electricity prices. The gas prices in America are 1/3 of the gas prices in Europe. What means competitiveness is very important for us, so it has to be a solution between these three things, and it's a very hot discussion in Europe what comes out for 2030. I come now to the emission limit, the low emission energy systems, to our regulation and legislation related to emissions. The main piece of legislation in the European Union, and I think you have heard about it, is the so-called emission trading scheme. I think we are, besides some countries like California and some regions in the world, we are the only big region which has this so-called cap and trade system for CO2 emissions. And this system is in place already for, I think, 13 years. And is our so-called market-based instrument to incentivize low-carbon technologies. And the EU emission trading scheme comes to the next period from next year, 2014, and the price is nowadays quite low. And this is a big discussion to revise this ETS system to come to a higher price of CO2. The other emission-related legislation is about SOx, NOx, and particulates. The Large Combustion Plant Directive is regulating the emission limit values for all kinds of industrial installation, including large combustion plants, including coal plants, and sets the limits for the installations. And the limits are very strict, what means the last revision of this Large Combustion Plant Directive in 2008 applied new, stricter emission limit values, and the existing power plants have to retrofit their power plants to comply with this emission limit values. There is a deadline for the power plants, end of 2014. And now we have this process that you have to make a decision, the utilities have to make a decision to retrofit their coal power plant by modern state-of-the-art ESP desulfurization, also best technique, and to invest in this emission equipment, or they have to close the plants. So that means we will have quite a lot of many plants to be closed at the end of 2014, particularly in the UK, where you know that there are lots of plants without SOx, NOx equipment, and they have to close the plant. That is a strict legislation. And then I have to add, we have a new legislation already in place for the next years, the coming years then for until 2020. So, which comes in power already now for new power plants for 2040. New power plants have already adapted much more stricter limits than before, and existing power plants they have a transitional period. That means they can they have to invest or to close the power plant until latest 2020. So, John already mentioned the main issue for carbon capture storage, energy infrastructure, and we in the European Union have created a new financing instrument for energy infrastructure, and the new quality of this financing instrument that we fund CO2 pipelines. Transport pipelines for CO2 can be funded by the European Union by this facility. So that is in place to get CCS deployed. Now, very short about our CCS status in Europe. We know that there are 6 conditions for successful CCS. That is legislative framework, successful demonstration, commercial viability, public acceptance, infrastructure, and innovation. And this is the table where you see where we are in Europe. And I have to say, especially legislative framework is in place already since 2009. The successful demonstration, and John showed a slide about this for the global perspective, is not in line with our plans. We wanted to have 20 large-scale demos, and we made available different fundings for this large-scale demo, but up to now there is no demonstration plant operating, and we work on this very hardly. Commercial viability is linked with the ETS price. I don't go into this in detail. Public acceptance is quite a big challenge, and we work on this very hard because we are facing opposition by the public, in particular in terms of onshore storage. Infrastructure I already mentioned, and I come now to the main point of innovation. Because we say innovation, research, development is very, very important to come forward with CCS. And here you see the overview of our Clean Coal CCS research program. We have an overall research program, so-called FP7, and in the last 7 years we funded Clean Coal 100 millions on these technologies from European budget. And I show you only one example of a project. I don't go in details, although I could make a longer presentation about different projects, in particular international projects. But this is a project which we have with Indian partners. So we published this tender because it was an outcome of our EU-India Clean Coal Group to say we have to look, we have to help, we have to support India in tackling the problem of high ash content coal. And this is a project which is really only on the benefit of the Indian side. We don't have such high ash content coal in Europe. And the project is done with IIT Madras. I met them on Wednesday to speak about all the procedures and Thermax. And also Turkish partners are participating in this project. And if it is finished, then we hope very much we get a solution for pilot gasifier for the high ash content Indian coals. Other relevant instruments, Research Fund for Coal and Steel. Then we have Europe Aid funding, and this Europe Aid funding goes to this project. I already mentioned it. That is this project, TrackStep project, where we fund this cluster building. I don't go in detail, it's only to show you. We have a second project, the so-called VEC project in India, to develop a sustained clean coal technology capacity in the power sector. And we have a further project, the roadmap training program for renovation, modernization, and operation and maintenance. This is a project which we contracted with STEAG Energy Service, and I will get out, the main target is to get an action plan for R&M and O&M for the Indian thermal sector. The Ministry of Power, CAA, and NTPC experts are close involved in this project, and we hope very much that we get very good proposals and a proposal for a training program in the power sector. My last slide, I will show you only what comes up in terms of research and development, research and innovation in the European Union. We have a new research program with a high budget for all energy technologies, and we will continue our research on efficient and flexible fossil fuel power plant technology and carbon capture and storage. So we will continue to support R&D projects in this field. That is decided by the European Union, and that will be continued until 2020. And my last slide, I will underline that we wish to have increased collaboration on CCS between global players and European players as research institution, and we wish also to have more cooperation on research and innovation on clean coal and CCS with countries outside of Europe, like India, like America, and so on. So our invitation, and this is what I would like to say at the end of my presentation, is we are open for cooperation with Indian partners. I know that BGL and other institutes and companies have a very good research and innovation department, and I would like to invite you to cooperate with European partners. We have funding for European partners, we don't have funding for Indian partners, but we hope very much that we can get projects. And I would like to introduce my colleague, Vital Dage from the European Business and Technology Center. We have such a center here in India, and he will tell you some words about the center. This center is responsible to facilitate partnerships on research, to facilitate partnerships on projects, on cooperation, and he will give you a short information about their work. Thank you very much for your attention.
Also, I will very briefly talk to you about my center, European Business and Technology Center, and a very recently released report on the clean coal technology potential for India, and especially from an SME perspective, small and medium businesses perspective. Can I have a presentation, please? In India in 2008, we are almost 5 years now, but very actively collaborating and supporting European clean tech companies and research institutions. For now, especially we help the European research institutions and small and medium companies in their market entry to India, and offers hands-on support on the early stages of market knowledge to market entry to their expansion. We work in 4 clear sectors of clean tech: energy, environment, transport, and biotech. And EBTC has offices in 4 Indian cities: New Delhi, Kolkata, Bangalore, and Mumbai. So these are the 4 sectors, which are, we offer end-to-end solutions, as I mentioned, and these 4 key sectors, we say as the clean tech, promoted in India, and the one of today's interest on clean coal falls under sustainable energy sector of EBTC. As a connecting platform between business and government, EBTC assists European players to compete in this fast-growing sector in Indian market by highlighting the potential market access issues and have a feedback mechanism for the political dialogue between EU and India discussions, which Dr. Marriott just now mentioned to you. EBTC has around 30 consortium partners comprising of Chamber of Commerces to universities to cutting-edge EU research institutions in clean technologies. Well, this is our business model. The prime focus of EBTC is to provide a platform for EU-India collaboration in clean technology. We have access to Europe-based network of companies, research institutions and organizations that are open for joint ventures with Indian companies, with Indian SMEs, and also the research collaborations with Indian universities. The way that we work is to look at what are the cutting-edge technologies that are happening elsewhere and have a bridge between India and Europe through these models: research, innovation, to business, technology localization model. Both technology incubation as well as the business incubation is something that EBTC does through our 4 offices. Well, to the current context of the clean coal, whether one can hate it, for being one of the most polluting and highly natural resource intensive sector, the coal industry will continue to be the base load provider. So hence, making this sector clean is something of relevance to all of us. So hence this focus on the clean coal technologies. EBTC started focusing on this sector because most of the inquiries that we get is either on solar, on wind. When we talk about the clean technology, that is the reference which is made. But the coal sector, as I said, still needs a lot of enormous opportunity in terms of clean coal sectors. Hence, EBTC started with an effort to study what is the potential for this sector in Indian coal sector. Let's look at it from an SME perspective. And hence we come up with this study, which is just released last week in the 8th EU-India Coal Working Group, just last week in Chennai. And the study explores the business opportunities in the Indian coal-based power value chain for the European small and medium enterprises that specializes in clean coal technology. The study also provides a general overview of the Indian coal-based power value chain in its 3 pillars: the coal mining, coal logistics, as well as the power plants. So all the 3 value chain of the coal sector. Now there is significant scope for reduction of GHG emissions in this 3 pillars, all the 3 pillars. But I see a predominant focus here, the audience, you're all interested in the power plant clean coal technologies. But the study looks at all the 3 value chains of the coal market. So one of the goals of this study was to present a range of existing clean coal technology expertise, and this report has a list of 32 SMEs, the small and medium business companies who are interested to have collaborative interest with India. So hence it becomes very important to be a platform to connect EU and India efforts in the clean coal sectors. Well, this is something on the mining. The study has this report. I encourage you to download this report. This has been uploaded in our website by visiting www.ebtc.eu/reports. Also talks about some issues with the coal logistics. And this is something of interest to all of us here who have assembled. Yeah, these are some of the sample clean coal technology transfer potential that the study has identified, in which term, whether it is a medium term, long term or a short term potential. So you see the recent, the clean coal technology potential for CFBCs, for IGCC, for clean coal, carbon storage, and the UCG, the oxy-fuel combustion potential in the study. There are funding opportunities which Dr. Marian just now told, and also she also has mentioned the Optimat project. So there are other research funding sort of potential collaboration that is possible under Horizon 2020. Yeah. In conclusion, I would like to mention that study looks at the main advantage of the study is to look at the European companies having to have a collaboration with Indian companies. So hence, please download this report, and I would request Dr. Mariam to hand over this report to TrekStep, just an initial phase of having an interface between EBTC and TrekStep. So I would request Dr. Jawahar to come forward and receive a copy of this report as a symbolic representation of this collaboration. Dr. Mariam. Thank you very much.
Kindly to the audience. Sir, I can request you to Dr. Marian. Thank you very much. Come to the main conference sessions. I would like to make an announcement. Due to some unavoidable personal reasons, Dr. Garcia Pena from Elcogas Spain is unable to make it to the session despite his keenness. But we are glad to also say that Dr. Dobrin Toporov, Head Process Simulation Group of Thyssen Group, Uday, Germany, has graciously consented to present the vital slides on IGCC in addition to his own session on coal gasification.
Good morning, ladies and gentlemen, dignitaries in the hall. It gives me great pleasure to present about the modern design and upgrading of 4 power plants here among the august audience from the industry. I work for Doosan Power System India, and I head the boiler basic design. While our company is involved in most of the spheres which are the subject matters for today's discussion, I would like to discuss about the R&M and in a way of improving efficiency. Just to go about what the company legacy is all about. Company Babcock and Wilcox was originally established in 1891, and then slowly branched off to Babcock in UK at some time, and after some time we've got Skoda. Recently we have the company Doosan has acquired Skoda as well, and you can see the Skoda company also progressively from the years of 1920. Basically they are very, very old companies, but very long standing in the industry in terms of supplying boilers and turbines, steam turbines. So we are Doosan Power Systems. In fact, I wanted to just tell you that I'm standing in for one Mr. Andy Timms from the Duke TBS UK office, who was actually present this in front of you. Yeah. So that's how the technology holding has been transferring It was 1867 when the BMW partnership was there, and then it became US BMW and UK BMW sometime between 1881 and 1891. And 1995, this company bought Mitsui. Mitsui wanted to kind of own the shares of UK BMW, and it became Mitsui Babcock Energy. Now Doosan has recently acquired those shares, and now there is a Doosan Power Systems. That's how it's become Doosan Power Systems after it acquired in 2006 and 2007. Doosan acquired this company. Now let us look at the product line. The company as a group delivers in the area of power boilers and the power plants. Basically, we're there in every part that we could think of in the boiler and the turbine island. We can supply the boilers, all the complete pressure parts, non-pressure parts, pulverizers, burners, and even aerators and even DCS. We've got an installed generation of about 123 gigawatt of subcritical as a group, and then supercritical boilers we have got about 44 gigawatt, including about 13-14 gigawatt in India, and we've got about 7 gigawatt of CFB experience as well. And these are some of the recent projects. I don't want to go too much into the details, but we have had quite a bit of success in the recent years in the Middle East, in the South America, in India, and even the Southeast Asia. So those are the projects we have won, and we are executing some of them currently. And not to forget the current recent projects which are also related to this concept of efficiency improvement and advanced supercriticals. We have supplied boilers to GMR, basically 2 into 685, and even before that, you all know that we have supplied the 660s in the CPAR, NTPC CPAR, and we have got also the experience of 800 megawatts in Mundra, which we supply to Tata Power. And recently, we've got this contract from NTPC for Kudgi and Lara, which is under the phase of execution currently. It's in very advanced stage of engineering, and in fact, the erection has already started. The other project recently we won in Korea is 2 into 1000 Shinbonyeon, and the design is also in a very advanced stage. We won this contract in March of 2012, and the manufacturing is on. Over to the manufacturing capability of the company. We have got factories in Doosan Power Systems in India, in Chennai, in Punamalli, and we have got the factory in Veena, which was also set up recently. Both of them have about 2 gigawatt of capability per annum, and of course Doosan Heavy, which is in Changwon, has got a 5 gigawatt of capacity per year. Now I'll slowly move on to the relevance of today's discussion. Why R&M? When you look at the various options that we have, we can either look at going for a new plant, of course, which is a business by itself. And when you look at options, particularly India is a very important context because there's a fleet of boilers which have been supplied more than 30 years ago, which are all ready for R&M, and you will see that every year CEA kind of lists a certain number of projects for R&M, but after some time you will see something coming as an obstacle, and those projects don't kick off. But still, if the R&M can happen, there is quite a good potential for us to improve the efficiency, and let's see how that is possible. This is a very famous slide among the people who talked about the carbon abatement. Basically, I think our ED, PHR, Mr. A.V. Krishnan also mentioned about this morning. I was glad to see him also mention that on the long term, although carbon capture and storage is going to take over, probably on the short term, the supercriticals are going to fit in the basket of improving the efficiency and reducing the carbon footprint. Now, also, I would like to append to that. For the old units, R&M can also be a solution to append to what was said there, and this can actually help us reduce the carbon footprint and make it a cleaner it's a cleaner technology. Basically, by R&M we can make energy efficiency improvements. So also. If you see the major benefits, it magnifies the R&M. You can have the overall expenditure very minimum, and it will extend the capacity of the plant, extend the life of the plant by over 20 years or more, and then it will also maximize the use of the existing infrastructure. The most important thing is in India we face a lot of hassles in clearing, obtaining coal linkage and other permits. Now those are not going to be there when you go for an R&M. That's the best side of looking at the R&M. And also, even the IBR, one of the clauses, regulation says, 391A says, it is a mandatory thing that we have to do RLA for after the 100,000 hours of operation, and it'll have to be a major R&M after 25 years. So, going in line with that also, I think R&M is a very important thing to focus on in India. Next one. So, when you look at the R&M modality, we can renovate and maintain through framework agreements. I'll give an example of what Doosan Power Systems has done in the UK, and we'll also go through the methodology of how the R&M kind of goes. Now, we have to explore these options in India, but in the UK, Doosan Power Systems has had the success of having a long-term agreement of 7 to 10 years agreement for R&M. And what benefits this kind of an alliance brings with it is that the flexibility, and there is a benefit which is mutual. There are mid-course corrections that you can do to what terms you have got in the alliance. You can change them according to the situation. You can revisit the agreed mechanisms, and the rate increase there will be a clause, so that can be the best part. So generally the R&M goes in 3 phases. You do the plant condition assessment and do the post-assessment analysis and the boiler redesign. Then you go for actually the refurbishment. So the typical issues we come across, plant operating beyond the design length is a very common sight. Changing modes of operation, you want to move from fixed to base to peaking, whatever, and based on the demand and requirement of more operation flexibility because of the constrained things that the old boiler will be going through. It will look for some flexibility, and then you may want to also look at alternate fuels being fired, and material degradation and corrosion is also a very often sight. When you look at the life management, you look at various aspects and the pressure part, which are very important to study. The creep, the fatigue, erosion, corrosion, overheat, and host of things, particularly with the pressure parts. We have a lot of variety of things to look at, which I'm going to be elaborating in the next session. A parallel session is going to start at 2 o'clock. So anyone interested might be interested in joining that. Let's move to the engineering approach that we follow. Basically, we require to assess the impact of the past, how much the boiler has suffered, how much toll it has taken is a very important thing to kind of look at before we jump into the R&M and make solutions. Now, we have to explore and understand what were the margins and where the unit operated for a longer time. And then we can actually predict what's going to happen. So the fatigue and the creep come from the pressure cycles which happen. So the data, which is the operating data, if it is available, is a very important thing to form the basis. And we have to see for what time of operation the boiler was within the temperatures were within the design limit or exceeded the design limit. So that will be useful data to start with. And the next one would be that from the history we can assess the damage and we can make future projections of what to assess, and we can also assess the remnant life on that basis. There is established methods which can be used to do this. You can look at the creep damage and the fatigue damage, and you can establish safe zones for the operation. You can establish where the boiler should not be operating in, or any particular part which is affected by the creep or the fatigue damage should not operate in. That can be established. Now we have got various testing and modern tools which can assist in ensuring that we do this R&M perfect. Basically, thermal imaging is available nowadays, and a company has done it in the past for various projects. You can accurately measure the surface temperatures and make an assessment of what's happening. The 3D laser scan is also an important technique that can be used, which can improve the assessment by visualization. And we've got the in-house tools which help us arrive at the various parameters as is performance, and then suggest where the operation should get to, or what to predict basically when you change the fuel or when you change the conditions of operation. Usually the boiler is going to work to what the turbine will demand of the R&M, so you'll have to see how that will fit in when you do the R&M. So we have in-house software which are shown on the screen here now. BW Hot, and basically it's a Babcock program, the Babcock Wilcox program. The steam jet, which is also a program developed within the company to establish what's the predicted behavior. And also we can employ CFD for optimization. And that's a picture of multi-fuel burner test facility which is in Glasgow, Renfrew. Basically, it's got a lot of capability. We also, other than what you see on the screen, basically they have laboratory support services available which can do the chemistry analysis. Basically, you can analyze the fuel, you can analyze the material, you can analyze, do mechanical testing, NDT, metallurgy, welding, instrument calibration and emission. So these are all in-house done in our factory in Renfrew. Now we'll look at a panel, a project that we experienced, we executed very recently. Basically it's a unit which is more than almost 30 years old, originally supplied by ACC Babcock, and it's basically near the end of life, and the tender was out and we participated in that. The R&D was done by the customer himself. We didn't have to do it. In 2011 they conducted, and the results were part of making the specification. So it's that's the capacity basically. Oh, sorry, I'll move to previous slide, please. So that's the capacity of the boiler, and it was the year of installation 1982, which means it's more than 30 years. The unit is having a steam turbine of LMZ from LMZ. So the R&M was just not the boiler, it was also a boiler and turbine R&M. We'll see what the results we got. So before the R&M, this was a scenario, basically very high air infiltration, natural, and the turbine heat rate was quite high and much higher than what it was originally, obviously. And then you got very high power consumption with high air ingress and other issues. The coal GCV was not originally, it was 4,000 plus, now it has come down to 3,300, so that had its role to play. And the efficiency was down, the combustion was not good, and the other losses were also going up, and the load also naturally shifted because reduced because all the fans and other auxiliaries would not be able to support. The PLF was almost only 60%. And this is a project in progress, and so we will be able to tell you only the objectives. We cannot talk of what we have accomplished, but the objectives were to increase the life of the unit by about 15 to 20 years, which we have agreed to do, and replacement of various special parts, upgrading the coal mill capacity, reducing the power consumption, increase the turbine rating to 215 megawatt, and of course the supporting thing has happened in the boiler capacity also is now supporting the 215 megawatt, and the availability will have to be also improved. That's in the next slide. Then we guaranteed the following. I think 250 megawatt unit capacity, the PLF as per grid requirements. We have offered a heat rate which is better than what the expectation is, and we have agreed to bring the power consumption by 13 megawatt. All these have relevance to finally improving the footprint, carbon footprint, and other emissions. We are also fitting a low NOx burner, which you will see in some of the coming slides which are followed. And life extension, we have assured at least 15 years. And the particulate emission would be reduced to 90 from where it is currently, something like 350 or more. And these are the modifications we said we'll do. The blatant superheater upgrade, membrane, and reheat surface addition. It came because of the turbine upgrade, and the economizer modification to further improve the efficiency. And also there was the coal has actually degraded 20-30%, so that has also asked us to make some replacements to the aerator, which is not shown here. And we have to replace some of the burner panels. We'll see what are the areas we modified. Next slide. So that shows the areas that we modified, a part of the R&M. So it's a front wall arrangement. We are now going with low NOx burners in those locations. So that's we have also increased the mill throughput. We have put dynamic classifiers. We have done the skirt modifications, open bottom classifier, and dynamic throat, and we have increased the capacity of the mill by doing so. So also the fans had to be tinkered with. New ID fans and PF fans have been supplied. The FD fans are being refurbished to cater to the new demand, and of course the FD fan demand would actually be going down with the PA now increasing, but we had to refurbish it to ensure that it's able to meet the life requirement that we are promising, and replacement of all the control dampers which are involved in these. And then the ESP is being modified, new TR sets being supplied, and SPM now being agreed to be brought down to 90 milligrams. And the aerator, we have decided to go for the modular ones. It gives it eases the inspection time and the erection time, almost like comes from 3 months to something like 3 weeks. You can do the erection. It's easy to handle, and quite a bit of it has already happened. And now in the following slides you will see where the project stands. Also, although I'm not going to talk much on the turbine side, basically we have improved the efficiency, improved the heat rate, basically by doing some state-of-the-art turbine, following some state-of-the-art technologies that we have, which came in Skoda, some advanced blade technology and seal modifications which have helped improve the capacity of the turbine and make it also more energy efficient. And this is where we stand. Actually, there's a slight delay of about 1 month in the project, but right now we are in the phase of shutdown. Basically, we have started the erection work in a site has been mobilized and the work has actually started. I'll also talk about another success that we had recently, which is the Torrent project, which is a capacity increase from 110 megawatt that you see here to about 121 megawatt. We had similar superheated reheater coil replacements, capacity enhancement, efficiency improvement, but that's a very successful one, and it's running since last year very successfully without any issues. So we also did, as part of that, some RLA study of piping particularly, which we didn't do in the case of Vandal. There was a complete overhauling of the turbine valves, and they had to be serviced. And the complete hydraulic system was totally replaced to ensure availability and enhancing the life of the plant. And we had some challenges when we did that. Basically, drawings availability is a challenge. Tube design temperatures being matched, pipe design temperatures being matched. If you don't do that, you can get into an issue with the chief inspector of boilers. So that was a challenge by itself, and also obtaining the drawings is a common issue. The R&M looks good until you start doing it. You open a box of worms, you will see that you don't have enough drawings and information to actually do the R&M, and that's a challenge by itself. But in the end, you are adding quite a bit of life to the boiler, enhancing the efficiency, and increasing the capacity of the boiler, and you are of course improving the reliability of the boiler. So I'd like to conclude saying that it's very important to also consider this as a solution to improvement in efficiency. R&M is providing an opportunity, and there is a huge market in India which is for this. I think the policy makers also should recognize this and support the boiler manufacturers to ensure that whatever plans they make every year, they become reality at the end of the 50 year. Sorry, not every year, every 5-year plan. They make some plans, but some of the projects don't kick off due to various reasons. I think they should support us. Now, basically, this slide actually shows why it is important to do this R&M, because after 6 or 7 years of the overall, typically you will see the performance of the plant will never return to what it is in the original level. Now, that's what you're seeing, the ratcheting that you're seeing. Now, after major overhaul, there is a steady reduction, and then the design life actually ends at 25 years, 25-30 years. and there is a substantial improvement now possible. You are now not looking at improving the efficiency like in a subcritical to a supercritical. Actually, it's much more. You are very, very low in efficiency. You are emitting high, and these units are also contributing to the install base in the country. So it's very important to look at projects like Bandel and various other projects like other companies in India are doing. Mostly the market has been made available by the basically the policy makers aiding the R&D. Next. So just a comparison between the new build and the energy efficient R&D. Basically, what we want to project here is that you are definitely gaining on extending the life of the boiler. You are improving the reliability and you are also enhancing the efficiency. But also, it is also with a very less, much lesser capital. You are going to be able to improve the carbon footprint and all the emissions. You are doing the upgrade to the boiler by giving low-NOx solutions and other solutions. Coupled with that, you're also having an investment which is very less when compared to a new unit. So I think R&M needs its own focus and attention from the policymakers, from the utilities that own these boilers, and also the industry which supports making this happen, the boiler manufacturers. Thank you.
Improvement, the efficiency improvement in terms of the efficiency of the power plant, the LHV.
Right. That's it. So the efficiency improvement, the heat rate improvement would reduce the footprint basically from where it is currently. The unit is running at say 30% efficiency and you're bringing it up to 34 or 33. Now that's too much, but just for the sake of it, I'm saying now that's increase that. Basically, the unit is running there; it's already polluting. Now we have to focus on them as well, as much as we focus on building the new. We are not going to abandon the old plants because there is so much of good available in those plants. So it becomes important to also focus on R&D. Not that, as you are aware, we have all the new units also which we are supplying, which are advanced supercritical and ultra supercritical and supercritical. So the focus is being given here on R&D. That's it's dispersion theory. You know that, and there are standard chimney heights, and for the smaller capacities, you've got a formula to arrive at the height. And there's nothing being done on the NOx per se. NOx, definitely within the World Bank norms. We will not be probably 1600, 1500 milligrams or 1300 milligrams. It will be probably 750, 650 and the only requirement is that World Bank is heading this project, so they said it has to be at least meeting the World Bank norms. And we are complying with it.
Thank you.
We'll use CFBC for short, okay? And the title of this speech is a little misleading because anybody that knows anything about CFBC knows that the whole beauty of the technology is that it's capable of burning a wide range of fuels. So it would be Indian and other coals anyway with the right design and specification. So it's really what I'm going to try and do in this period is to talk about how circulating fluidized bed technology stacks up against pulverized coal technology, because I know that's the thing which is really quite interesting in this part of the world. My materials are not my own. They're actually two of my staff who have produced reports in the last 9 months one on CFBC developments and the other one on the comparison between CFBC and pulverized coal, which is what I'm concentrating on today. So let's start off by talking for a minute about pulverized coal. We know that it provides about 9% of global coal-fired power capacity. On the other hand, CFBC offers greater fuel flexibility and low-cost emissions reduction because you don't need FGD, you can do it with limestone embed for sulfur, and it's naturally lower NOx producing, although very high N2O. What we've been seeing, of course, why we have this reviving interest at large scale, is that the units have been getting bigger and bigger. For my sins, when I was working for British Coal, when such a company existed back in the 1980s, we were looking at putting in CFB units at some of our power stations, as pithead power stations. And at that time, the biggest unit anywhere in the world was about 100 megawatts electrical. That would be about the mid-1980s. Well, nowadays we're talking up to 600 megawatts, full utility scale. And so that's another area why CFBC has become interesting. You can see the main features, of course, on the diagrams on this slide. I'm not going to try and spend time talking about it, but just to point out, the supercritical PC boiler would normally be fitted in the Western world, be fitted with selective catalytic reduction. Would have flue gas desulfurization, though it's not shown there. Whereas the supercritical CFB, what we've got reheat with steam bypass, hot solid return system, of course, is the main feature of it. And the other thing that's particularly noticeable about, just carry on with PCC, coal pulverized 1300 degrees C or above, state-of-the-art ultra-supercritical units, as I was saying this morning, well, right up to 47% if you're designing for a base load, big unit, hard coal. But you do get problems with if you get deviations from design coal, or you go to high ash content and slagging fouling, you tend to build up the PC unit, so it's better to stay close to the design coal. Although, having said that, it's worth pointing out that these days a lot of organisations buy coals from different sources and either blend them or burn them sort of one after another. I was talking to people from Malaysia only recently, and they're having huge problems with their few coal-fired boilers, simply because their procurement people have been sourcing coal from all around the world and haven't realised that all black stuff isn't the same. And having operational issues. With CFBC, you've got this high pressure air suspended solids in a fluid-like state, so you get quite long residence times compared with pulverized coal, but you're combusting at much lower temperatures. 800 to 900 degrees C tends to be the norm. And as I said before, because of the sort of nominal staging you get in the CFBC unit, you get low NOx, and as I said before, simple DSOx by adding limestone or to the furnace. Pointed out that the size of CFBC units was growing. This slide tends to demonstrate that comparison with PC boilers. PC size since 1920, we've gone right up here. We've got units of over 1,200 megawatts in size. There's not very many of those around, but there's lots of units in this sort of area, 600 to 1,000. CFBC has been creeping up steadily since the 1980s, as I told you my personal experience, 100 megawatts around about the mid-1980s. And here we are, we're now creeping up, and we're up to 600 megawatts, which is, with 800 megawatts being commercially quoted. Here are some of the units that we talk about now being highlighted on this slide. So There's this one here, Łagisza, supercritical unit in Poland, been operating for 4 years now. This in China at 600 megawatts, being about to be commissioned, if I remember correctly. This one is in 550 is in Korea, and these are the manufacturers, Foster Wheeler, Alstom, Larvik, and Dongfeng. So Foster Wheeler, Alstom are well known in this part of the world, and then the two Chinese manufacturers as well. I thought we'd put a couple of slides in to show BHEL's experience by contrast. There's a slide provided by BHEL, so I hope they're up to date. So we're talking here, coming up this curve from the 1990s now, right through to about 250 megawatts, which will ring on Nebeli lignite. And so you can see that also you've been building up the experience. I can understand why you'd be wanting to use the CFBC or specifying it for some less attractive fuels, very high ash or like a lignite. But some way behind the best in the world in terms of both size and steam conditions. This is another way of showing that the BHEL CFBC technology development going up over the last 17 years, 18 years. So about first orders received in different sizes, and here again you can see starting very small, starting down 125 megawatts and getting up to 250 megawatts over that time. And it's interesting that the fuels were actually mentioned on this slide as well. Petcoke there, an order in Indonesia there, which might very well be burning a bituminous coal, I would guess, and the lignite up here. Here is a paper. Another lignite-based one. That lignite seems to have been sort of the most common, but it hasn't got to be the only thing that's can burn. There are CFBC units which are burning specified an anthracite. One thing I would say is that CFBC units do burn a wide range of fuels. There's no doubt that they can do. But like any other unit, they're probably best burning their specified fuel or fuels that they're designed for. As soon as you start moving significantly away from design specifications, you're likely to have other issues to deal with. Another one on BHEL boilers, showing the units commissioned in 2010. I've forgotten where SLPP units are, so somebody will probably tell me from the audience later on. The thing that's been developed in the last few years, apart from going up in size, is the fact that the designers have learned how to do these things with other supercritical conditions. We're not talking necessarily about the first ones being very high steam temperatures. This one in Poland, 460 megawatts, burning local bituminous coal. If my memory serves me correctly, was operating at about 540, 550 centigrade, something like that. It's a big steam temperature. The one in Weimar, China, 600 megawatt, started operation earlier this year, and that's specified on a high ash anthracite. The Korean one we mentioned is nominally under supercritical conditions, so talk about steam temperatures around about 600 or just above. And that's 4 550 megawatt units, but they're under construction. They're scheduled to start up in 2015 with 4 more to follow. And they're expected to burn a wide range of imported coals with up to 20% biomass. And that's another thing about CFBs. It's quite normal nowadays that manufacturers will talk about quoting burning up to 20% biomass, as well as coal or whatever. What is clear, I think, is that CFBC, because of its flexibility in terms of fuel, has been picking up global market share. We think that it's got somewhere between 5 to 7% of global coal-fired power plant capacity, and I don't know where the projections for 12% growth per year come from, but that was something that was we reported. And the motivating factors, response to stricter emission limits, exploiting cheaper fuels and availability of other cheap fuels, particularly waste products, waste coal, pet coke and so on. And given that these days power companies are finding they have to source power companies which are importing, which is a lot, having to source from different markets, they feel it gives them some flexibility. Regarding efficiencies, combustion efficiency, well, there have been problems reported with high residual carbon for some CFBC units. That's probably to do with controlled operating conditions. Boiler efficiency with in-service desulfurization allows lower boiler exit temperatures, so boiler efficiencies are good. On thermal efficiency, well, overall, maybe not quite so wonderful because you've got fluidizing air fans consuming more power than possibly get used with FGD and pulverizers with the PCC systems. But supercritical steam has allowed us quite a big jump up in CFBC efficiencies. We're seeing 42-43% now, that sort of figure, which is much higher than 10-15 years ago. On auxiliary power consumption, plant power can be reduced by optimizing the fluidization state, but that does require controlled fuel size distribution. So that's not going to be quite so easy to do. And you can see from the graph there that once you can save some energy, there's the auxiliary power there. This is pulverized coal with flue gas desulfurization. And these are all the manufacturers' names. It's all the units rather. Listed along the bottom there. Where CFBC probably doesn't stand up quite so well with PCC is on load following. Because of that big thermal inertia that you've got in the bed, with all that big inventory of material there, it's not so easy to ramp it up and down quickly. Although on the other hand, hot and warm restarts are relatively easy because you've got this big residue of warm material. Transient and low loads tend to be not so good for desalt purposes. On ash, very high ash coal can be used in CFBC. We have seen examples of, well, of course, Indian coals are very high ash coals, most of them, so pretty suitable for that purpose. But low temperatures tend to reduce slagging and fouling, although even in those conditions, there are plenty of examples of better collaboration being a problem. One of the things which makes me wonder a little bit about Indian coals with CFBC, and some of you guys probably know more than I do, is that erosion damage tends to be quite a concern in some CFBC units, particularly of the tubing. I know that Indian coals are very abrasive, but I'm not quite sure how that runs in CFBC units. But I can imagine there can be some issues and problems with some special design requirements. Initially, when CFBC was sort of getting up to still sizes, there were a lot of problems with availability and reliability. China had a lot of, went up a big learning curve to get it working. But things have improved. This slide lists a number of different units. So what you see on the left-hand column of the numbers is the initial availability in the first year of operation of different units, and you can see figures there of 59, 87, 78 and so on. And then you can see the availability in 2012, last year, and all of them running very much better and much more steadily. So people have learned how to manage these beasts. Well, this just shows the PCC options for fluid gas desulfurization, principally wet FGD or spray dryer FGD. That dry active coat system that I was talking about for Isogo this morning, the Japanese system, isn't widely disseminated, although it's very interesting that, as an aside, it's very interesting the Chinese are looking at adopting an almost identical system for their power station building to the west side of China, where they've got water problems. On NOx emissions, circulating fluid produces about, or a lot less than pulverized coal, about 60% it says here. Sometimes SNCR is added to meet limits, and there's stuff here about relative operating costs. You can see that, the SCR, SNCR, CFBC plus SNCR, to try and get our levels down using ammonia, moderate use, and then the relative operating costs. And these are not numbers because we don't have numbers, we're just for the relative cost of these things. SCR very expensive on its own. Noticeable that the boilers of Samchuk in Korea would use SCR to be a very low limit of 50 ppm of NOx, and it may be necessary for all these large boilers in order to get down to low NOx levels. Nitrous oxide, N2O, is a particular issue with CFBC units. N2O is produced in significant concentrations, but we're talking the ppm level, it's still significant, because has 300 times the greenhouse effect of CO2. So we do think that at some point, if the CFBC units start getting widespread, then there may well be regulation coming in on those issues. Could be abated with SNCR or certain catalytic reduction or after burning, but of course that adds to expense. On ash recycling or reusing ash, CFBC again has a little bit of an issue compared with pulverized coal. You get high levels of limonite hydride in CFBC ash. It tends to be self-cementing. It's not approved in most jurisdictions for use in concrete. A lot of PCC ash gets used that way, but not a lot of CFBC ash. So it tends to get mostly used in mine reclamation activities, neutralising acid soils or sealing off acid drainage. And there's some specifications there for PCC ash versus CFBC ash. So the CFBC column, silica versus PCC 52.7. They're really quite different, as you can see, quite different specifications, so quite different materials. So CFBC ash tends to get low-grade construction applications, waste sterilisation, agricultural use, and of course you get more of it with CFBC because you've got the added limestone, whereas the pulverised coal produces wet FGD, with wet FGD rather, produces coal ash which can be sold and possibly gypsum. CFBC also gets used widely can be used with biomass firing and co-firing in Sweden and Finland. Actually, that's a misstatement. I'm going to take task on my guys for that. I know that CFBC actually started out going way back with small thermal units back into the 1960s and 70s as a technique, burning up wood wastes. It was only later that CFBC started to be applied to coal. It started with burning wood wastes. But today, most large CFB units produce, particularly Foster Wheeler, offer a 10 to 20% co-firing capability as a more standard thing, so that can be quite useful. You can feed coarser fuels. You don't have to go down to the extent of pulverizing down to small micron sizes. It says here you get less problems with slagging. That's because of the lower temperatures of operation. But agricultural waste can cause problems with CFBC. There must be some instances of getting agglomeration problems when producing certain agricultural wastes. I want to say something just in passing about oxy-CFB, oxy-fuel-based, air separation using oxygen. This is a technique which I know you're interested in here in India, BHEL in particular, but other organisations are looking at it as well. The picture on this slide is of a facility at Thuid in Spain, which is a splendid place for testing CFBC for oxy-fuel combustion. It's been this particular thing, and they actually have a PC unit next to a CFBC unit for comparative purposes. It's actually a Foster Wheeler supply unit there, and they're also linked to doing carbon capture. What they say is that the heat transfer from circulating solids allows higher oxygen concentrations, gives you a smaller boiler. They operate at positive boiler pressure, so that reduces air ingress, and the lower excess air that you use reduces oxygen demand.